Jai Hind everyone. I am Abhishek Gupta, working as a scientific officer in AKGC Skill Foundation. Today I will present one of the emerging topics in the field of welding, that is the welding of aluminium by gas tungsten arc welding process. These are the topics which I will cover during this session. Firstly, I will tell you what is aluminium actually is and what are their classifications of aluminium. Then secondly, we will go on to the applications of aluminium and the weldability issues related with the welding. After that we will cover the history behind gas tungsten arc welding. Then further we will discuss about operating principles involved in gas tungsten arc welding and what are the various setups we generally used in tungsten inert gas welding. Then going on further, then we will discuss the advantages and limitations which we will see in gas tungsten arc welding. After that we will further see the various equipments which we generally used during performing the welding of aluminium with the help of gas tungsten arc welding. After that we will further go and study about the consumables and different parameters which we generally used during welding operations. Then we will see how the welding has to be performed with the help of gas tungsten arc welding on aluminium profiles. Then at the end we will discuss some advanced welding processes related to gas tungsten arc welding processes in this slide. So coming on to the aluminium, actually aluminium is the third largest abundant element after oxygen and silicon. It was first discovered by H. Davy in 1808, and it has various properties of aluminium, that it is having a very light weight whose density is around 2.7 gram per centimeter cube. Due to its light weight characteristics of aluminium, it has been widely used in various applications. Apart from being a lightweight, it also possesses a higher strength, and this higher strength can be achieved up to around 450 Newton per mm square. Apart from the high strength, it also has a non-corrosive property, and it is also non-toxic. And being non-corrosive in nature of this aluminium, this type of elements can be used in a variety of applications, and its toxicity is also very negligible, so its popularity again is very vast throughout the entire region. Apart from that, aluminium is also non-magnetic. We can see that the pure aluminium has FCC structure and it is very ductile. So coming on to the classifications of aluminium, we can see that generally aluminiums are classified into three categories. First is pure aluminium, then second is wrought aluminium, and third is casting aluminium. And coming on to the further classification, we can say that the Aluminium Association has devised these classifications of aluminium into various categories. Aluminium Association of USA has categorized these aluminium classifications based upon American Society for Materials and Testings in basically total 9 different categories. First is 1XXX, that is, it is of pure aluminium. We can say that this one number represents that it is the pure aluminium, and the second digit, that is this X actually represents some consecutive modifications in the original alloy which we generally see in the aluminium, and the last 2 digit actually indicates minimum percentage of aluminium which is generally used in the aluminium group. Then the second aluminium classifications, we can see that starting from 2XXX to 9XXX, when we add an alloying element in the aluminium, then depending upon what type of alloying element you are adding into the aluminium, based upon that there are further classifications starting from 2XXX to 9XXX. In this first digit actually represents the alloying element, that which alloying element is major in this aluminum alloy, and the second digit indicates consecutively the consecutive modification of an original alloy, and the last two digit generally has no significance. These are the groups of various aluminum alloys. You can see here, like 1XXX series, 1XXX series, generally we can say that it is a 99% pure aluminum is there in this type of series. Being having higher purity in case of aluminum, we can use this type of aluminum in electrical industries. Then coming on to the 2XXX series, some amount of copper is added into the aluminum. Being as you know, copper has very good conducting properties. Due to this, it has been largely used in the aircraft industries. Third is the 3XXX series. In 3XXX series, we can see that the manganese is added in the aluminum, and due to manganese addition of the aluminum, these types of aluminum alloy can be used for the home appliances, because manganese have the property that it can be add the you can say that it can easily fold any material into its shape. Then fourth category is 4XXX series. In this, silicon is generally added in with the aluminum. Due to adding of the silicon, these types of aluminum alloys can be used for brazing alloys and for the filler materials. Actually, brazing is a process of joining two materials with the help of filler materials whose melting point is above 450 degrees centigrade and below the melting point of the base metal, and the filling of these filler material generally causes through the Kepler reactions. Then fifth is the 5XXX series. In this, magnesium is generally added, and these types of aluminum alloys are generally used in marine industries. Then another is a 6XXX series used for welded structures. Actually 6013 and other aluminum series are very largely used in different fields for welding structure purpose. Then coming on to the this 7XXX series, here we use zinc as the major alloying element in one of these aluminum groups. So using zinc, these type of aluminum alloy can be used in military applications. And in the last, we come to the 8XXX series. Here other alloying elements are generally added, and these types of aluminum alloys are generally used for the heat exchangers. I have already told you that aluminum has various applications in the field of various technologies, you can say. So these are the various applications like automotive industries, aerospace industries, marine industries, defense, high speed trains, and construction industries. So you can see that aluminum is generally used in every mode of life during our course of interchange. Then before starting to discuss about the aluminum weldability, firstly we will see what are the weldability issues we generally face during welding of aluminum. So we can see that the first issue is that the aluminum being an active material, so it get easily oxidized. Due to the easily oxidation of the aluminum oxide actually forms on the surface. As the aluminum oxide melting point is very high, that is around 1926 degrees centigrade, and the melting point of aluminum is around 660 degrees centigrade. So being the larger variations in the melting point of aluminum and aluminum oxide formations on the plate of aluminum, its welding becomes very difficult with other manual operations like SMAW or other processes like oxy-fuel welding. Then second weldability issue which we generally face is the high thermal conductivity. The thermal conductivity of aluminum is around 3 to 5% high than that of steel, being the high thermal conductivity, the heat generally doesn't concentrate at a single point. Due to this, we see that there is a lot of heat loss which we generally take place in the case of aluminium. Then the third weldability issue is that it has very high thermal expansion coefficient. Its thermal expansion coefficient is around twice that of steel. Being the high thermal expansion coefficient, we generally see that higher heat affected zone is generally seen in case of aluminium due to this property. Then fourth is the low melting point. Since the low melting point, aluminium has the very low melting point, so it becomes very difficult to control the arc when we use some type of processes where the current is very high. Then fifth is the absence of color change as the temperature approaches the melting point. In welding and different types of materials, which we generally see that when it approaches its melting point, then there is some color changes we see in the material. But in the case of aluminium, while welding the aluminium, we generally see that there is no color change is generally observed during welding. So it becomes very difficult to find out at what temperature, at what instant we can actually weld that material. So these are some weldability issues which we generally see. So coming on next, we can see that there are various welding operations through which we can perform welding. So but in order to weld aluminium, there are various welding operations like gas tungsten arc welding, gas metal arc welding, plasma arc welding, and so on. So coming on to the history of gas tungsten arc welding, we can say that initially, before the development of gas tungsten arc welding, shielded metal arc welding and oxy-fuel welding was developed. But we can see that in 1890, Gtaw had its beginning from an idea by C.L. Coffin to weld in a non-oxidizing gas atmosphere, which he further patented in 1890. Then in 1920, H. Hobart give the further concept has been refined, in which he uses helium as the shielding gas, and Devers after that uses argon as the shielding gas. Then in further we have seen that the inert gas shielded process developed by Hobart and Devers was ideal for welding aluminium and also for welding stainless steel and magnesium. Then in 1941, Meredith patented this technology with the name of heli arc welding, where he uses helium as the shielding gas. Then in 1945 further and so on, Linde Air Products has used water cooled torches and developed and add more fragrance to this technology through which we can actually weld the aluminium with the help of gas tungsten arc welding process. So you can see that the gas tungsten arc welding is also known as tungsten inert gas welding. It is also known as argon welding when we use argon as the shielding gas, and also we can say its another name is heli arc welding, where when helium is used as the shielding gas and heli arc is developed during the welding operations. Another name is Wolfram inert gas welding. Actually, Wolfram is the German word of tungsten. That's why tungsten inert gas welding is also known as Wolfram inert gas welding. So you can see here that the gas tungsten arc welding is a manual operations through which generally non-consumable tungsten electrode is used, and this non-consumable tungsten electrode is used to join different types of materials with the help of concentrated heat which is present between the electrode tip and the workpiece surface. Here, apart from these workpiece and electrodes, we also use the shielding gas, and this shielding gas actually flows inside this gas nozzles and passes through this over this bead, and this shielding gas actually covers this molten pool from atmospheric contamination, so that atmospheric gases doesn't contaminate this weld bead, and we generally obtained a good weld bead during welding. So you can see how the welding has been going on. So how to weld aluminium? So you can see that the gas tungsten arc welding process is the process that has to be found to be the most appropriate metal joining technology in order to weld the aluminium, because previously process which was available was not enough, or you can say was not appropriate to join aluminium, being various weldability issues faces during welding. So coming on to the gas tungsten arc welding process, we can say that it is the arc welding process. Arc is generally established between the non-consumable tungsten electrode and the workpiece. You can see here one end of the power source is connected to the electrode and another end of the power source is connected to the workpiece. This is the gas cylinder, and gas cylinder is passed through this power source and goes through this gun, and here the shielding gas gets concentrated. So you can see that the inert gas actually sustain the arcs and protect the molten pool from the atmospheric contamination. This process is also known as autogeneous process, because sometimes we don't use filler material in order to weld different types of component when we have to weld thin materials, because whenever we have to weld thin materials, sometimes it is not required that you have to add filler materials. So that's why this process is also known as sometimes this process is also known as autogeneous welding process. So you can see that the filler metal can be added whenever required depending upon what type of thickness you have to weld. Then there is the independent control of heat input and the filler wire addition. Due to the independent control of heat input and the filler wire addition, this process has these advantages. So coming on to the application of gas tungsten arc welding, we can see that there are various welding applications, like it is used in aluminium welding, root runs in pipelines, fabrication of heat exchangers, fabrication of stainless steel, aircraft frames, thin material welding, and fixing and repair mining works. So you can see that there are various applications also. So coming on to the GMAW equipments, we can see that there are generally 4 major equipments, that is the gas tungsten arc welding power source, gas tungsten arc welding torch, cable and gas hoses, and gas nozzles. Apart from these, we can use various types of, we can add furthermore equipments in order to upgrade this process, that we will see on the further slides. So you can see that this is the power source. Generally the power source of gas tungsten arc welding is a constant current type, which is also known as a drooping type. So you can see this is the power source which we generally you are seeing. This is made of Fronius company, and the most common power source is the transformer cum rectifier type power source. You can see here, and actually transformer actually converts high voltage into low voltage, and then this rectifier actually converts AC into DC. And there are various rotating AC or DC generators are also used for producing this constant current power source. And there are actually various polarities which we generally use during welding, like AC welding and DC welding. DC welding is further classified into direct current electrode negative and direct current electrode positive. That's why there is written that there are 3 types of welding polarities which we generally use in gas tungsten arc welding process. So this is the static characteristics of the power source. Static characteristics of the power source is that characteristics in which when there is a variation in voltage with variation in current, when there is pure resistive load. Okay, so you can see that this is the characteristic curve which is generally drawn between the voltage and the current, and whenever you take any 2 point, like you can see that here you have taken one and here one, and draw 2 lines horizontally and vertically and project on x-axis and y-axis, then you can see that the changes in voltage is very large in comparison to the changes in current. Due to the less change in current, we can say that these type of power sources are known as constant current power sources. And we also know that this process is a manual process, because we have to move your hand in order to weld any component. So, and also you during welding, your hand will be fluctuated, because you are not the machine that you can weld continuously while maintaining the arc length between the electrode tip and the workpiece surface. That's why there is always the fluctuation of arc length between the electrode tip and the workpiece surface. Due to this fluctuation of arc length, there is always the changes in fluctuation of voltage. Due to this fluctuation of voltage, this power source automatically accommodates this drooping characteristics, that there should be very less change in the current. Due to this less change in the current, we generally obtain very good weld profile, and that weld profile can be used in a variety of applications. So this is one of the Gtaw MAGICWAVE cold wire transfer technology machine which we have generally in our lab. And this is the why we are saying a cold wire transfer technology, because we are using one wire feeder with this machine, and this wire feeder, through this wire feeder, one consumable wire is coming through this electrode, and welding is being performed. So you can see that this wire didn't require any extra heat source for its melting. That's why it is known as cold wire transfer technology. So it is a semi-automatic process, because with the help of a wire feeder attachment, we have converted the manual process into the semi-automatic, as we don't have to use another hand in order to feed the filler wire to the molten pool between the, and the cold wire feeder is there, and water cooling attachment is there. So in order to see how the arc is generally started between the in gas tungsten arc welding. In gas tungsten arc welding, we don't have to touch the electrode directly to the workpiece in order to ignite the arc, because in the gas tungsten arc welding we generally use a high voltage, high frequency and low current type of power source, through which you can automatically ignite the arc between the electrode tip and the workpiece surface. Whenever you use the high frequency, high voltage, low current type of power sources, it automatically can synchronize with the actual power sources, and at the time of starting of the arc, you actually press that button, and whenever the arc get ignited between the electrode tip and the workpiece surface, then you can switch off that, and the normal manner you can actually go on your welding operations. So very less skill is required. There are various another method in order to ignite the arc. Another method is the scratch starting method. Means that you have to touch, scratch, and then start the arc between the electrode tip and the workpiece. But there is the chances of electrode contamination in case of scratch starting. So whenever electrode gets contaminated, then there will be the chances that the weld bead which you obtain during this welding operations will not be very good. So that's why you have to use gas tungsten arc welding processes in order to ignite the arc. In case of gas tungsten arc welding process, you use high frequency, high voltage and low current type of power source. So these are some of the welding torch details. Like you can see, this is the torch head, this is the long back cap, this is the collet in which generally 150 mm long length electrode, non-consumable electrode is fitted, and this is the collet body which we generally comes above this, and this is the ceramic cup through which shielding gas actually flows out. And you can see there is the gas lens body which converts the turbulent flow or any flow of the shielding gas into laminar flow, so that sudden disruption in the shielding gas you doesn't see during welding. So you can see there is the gas lens. So coming on to the torch type, there are actually two types of torch type. First is the air cooled torch and second is the water cooled torch. Air cooled torch are generally used for those types of gas tungsten arc welding process where we use a current less than 150 ampere. Whenever we go for above 150 ampere, there we generally used for water cooled torches. Water cooled torches are generally available in the market in the consecutive amperage range of 50 ampere, like 150 ampere, 200 ampere and 250 ampere and so on. So this is the cross sectional view of a water cooled torch. You can see here that from here shielding gas goes, and this shielding gas come out through this collet and covers the weld pool which was present here, and here water is going inside, then it is cooling all these attachments, and again water is coming outside by maintaining the temperature of this a torch in a constant manner, so that the temperature doesn't exceed and the torch doesn't get damaged. That's why water cooled torches are generally preferred. So these are the collets and the nozzles which we generally used in the water cooled torch. This is the collet. This collet is generally used to hold the tungsten electrode, and this is the nozzle which generally used in order to in order to flow the shielding gas through this body. You can see depending upon the electrode size, we can vary the collet size and the nozzle size. So you can see that generally the nozzle size are available in 1/16 inch, and these number when you multiply with this, it actually denotes the inner diameter of this nozzle, this ceramic nozzle. So you can see this is the pink color. Pink color is due to that it is made of alumina. If it is made of ceramic, then it should be white. Coming on to the TIG welding consumable. TIG welding consumables, there are generally 3 welding consumables. First is the tungsten electrode, shielding gas, and the filler wire. Filler wire is optional. Tungsten electrodes have the melting point of around 3410 degrees centigrade. Being very high melting point, we generally say that these type of electrodes are generally non-consumable. Its boiling point is around 5950 degrees centigrade, and when during welding it retain the hardness when it is red hot. American Welding Society has classified the tungsten electrode in total 9 different segments, depending upon what type of alloying elements, what type of oxides of thorium, zirconium, lanthanum, cerium you are taking in order to form the electrode. And this 2% denote that 2% thorium is used, 0.8% zirconium is used, and so on. This is the box of tungsten electrode. In one box total 10 tungsten electrodes are there. This is the tungsten electrode. Here classification is shown like pure tungsten electrode, thorium tungsten electrode, cerium tungsten electrode, and lanthanum tungsten electrode. Pure tungsten electrode, but color is actually green, and the thorium tungsten electrode is red, cerium tungsten electrode is orange, and lanthanum tungsten electrode is gray. Generally thorium tungsten electrode is banned in European countries because thorium has some amount of radioactivity property. That's why it is banned in other countries, but it has a very good ignition characteristics, and it has a very good current carrying capacity. Why we have to add these thorium, cerium, lanthanum? Because pure tungsten has not very good current carrying capacity. You can say that. So there are various tungsten electrode has various diameter, and these different diameter electrodes here has shown how the current has been, what type of current, what magnitude of current you actually use based upon what type of electrode diameter it is given. So you can see that 1.2 mm diameter electrode, in case of direct current electrode negative, current range is around 70 to 150 ampere, whereas in case of direct current electrode positive, in case of 1.6 mm electrode, it is current vary from 10 to 20 ampere. Similarly you can see further. So again, coming on to the electrode tip configuration, we can see that the electrode tip configuration, you can see that this type of electrode tip configuration you have to maintain while welding any component. So you can see whenever you, in case of DC welding, this is the length and this is the diameter. So L equal to 3D when diameter is less than 3 mm. Length of this conical tip should be equal to 3D when diameter of this tungsten electrode is less than 3 mm. When the diameter of the tungsten electrode is greater than 3 mm, then in that case we can say that this length of the tip should be equal to the 2 times of the diameter of the tungsten electrode. So in case of AC welding, you can see that this is semicircular shape is obtained, and in case of DC welding this conical shape is obtained. Why in case of AC this is there? Because in case of AC welding, 50% time electron hit this electrode, tungsten electrode, and due to electron hitting this tungsten electrode gets heated up. Due to this heating, it comes into, you can say, semi molten stage, and its profile gets changed. But in case of direct current electrode negative, you can say the electron doesn't hit this electrode. That's why the profile of this electrode remains maintained for a longer duration of time. During making the electrode tip configuration, you generally grind this tungsten electrode lengthwise, not crosswise. Otherwise, if you do crosswise grinding, then there will be the chances for the arc to wander, and there may be the chances that the inclusion can interfere during welding operations, and you can obtain a defected weld. So these are the shielding gas which we generally use in gas tungsten arc welding operations while welding aluminium. Because aluminium is I have already said that aluminium is a very active material. It actually react with the air present in the atmosphere, and this air also has some moisture. So aluminium generally obtain this catches this atmosphere moisture and get oxidized. So in order to avoid the oxidation of the aluminium, we generally use inert shielding gases like argon, helium, or the mixture of these two gases. We never use 100% oxygen or 100% nitrogen while welding the aluminium with the help of gas tungsten arc welding. So you can say that gas tungsten arc welding and helium gases has some shielding gas property, like it is the best shielding gas, best cleaning action, arc starting is easier. As you can see in periodic table, helium comes above or argon comes down. Helium is light in weight because it is situated above in the periodic table. Being light in weight, we have to increase the flow rate in order to avoid the contamination of the atmospheric gases to the weld bead. That's why you have to increase the gas flow rate in case of aluminium. Its gas flow rate is around 2 to 3 times that of argon. Due to the increase of the gas flow rate, its welding speed can also be increased. But as you know that the helium has higher ionization potential. Being higher ionization potential, its arc starting is very difficult. And in case of argon, it has lower ionization potential. That's why its arc can easily be ignited. Generally, during welding, we do back purging so that the surface at the back side doesn't get oxidized, or the heat affected joint doesn't change its color. So in order to avoid this changes in color or oxidation property in the case of welding of any component with the help of gas tungsten arc welding operations, we generally use different types of backing gas like argon, helium, argon, hydrogen, nitrogen, hydrogen mixture, nitrogen, argon mixture. So there are various types of backing gas depending upon what type of materials you have to weld and you can use these purging gases, like also known as backing gases, during welding operations. So these are the schematic profile for different shielding gases. You can see that as we go on increasing the helium, its penetration is increasing. As I have already said that helium has the higher ionization potential. Being the higher ionization potential, it actually gives a higher arc energy. Due to this higher arc energy, deeper penetration is generally seen here. So coming on to the filler wire, filler metals are used to add weld metal to the joint for reinforcement, making it stronger. It is not always necessary that filler wire is required, but filler wire we generally used when we have to weld a thicker material, or based upon what type of welding process specification is allowing you to weld any component. So filler metal is selected based upon the type of metal being welded, the type of shielding gas used, and the mechanical requirement of the final piece. So these are the classifications of filler material. Like ER308L is having stainless steel filler wire, and these type of filler wires are generally used for welding the SS304, 308, 321 and 347 series type of materials. So coming on to the designation of gas Gtaw filler metal designation, you can see here E represents the electrode, R represents that the electrode is in the form of rod, 70 represents the minimum tensile strength in PSI, and S represents the solid wire, and X represents the chemical composition of the wire. So coming on to the quiz time, we can see that first question is, Why does the GTAW process uses constant current welding power sources? So I have already told you, first option is so it can use any metal for its electrode. Second is so it can tolerate small changes in arc length. C is so that it can easily be automated. D is so it can be used on thicker material with high current. I have already told you that GTAW has drooping characteristics. So whenever there is changes in the arc length, it can easily tolerate. That's why gas tungsten constant current type of power source are generally used in case of gas tungsten arc welding process. Second is, so its answer is B. Second is, which of the following gas mixture is not used in gas tungsten arc welding process? I have already told you, in order to in case of gas tungsten arc welding, tungsten inert gas welding operations, we use inert gases. So this is not the inert gas, so it will be the answer will be A. Third is that there are various different types of parameters like voltage, current, travel speed, shielding gas flow rate, travel angle. There are various types of gas TIG welding parameters, but the most prominent parameters which we generally see is the travel speed and the shielding gas. So the travel speed should not be too high or should not be too slow. If the travel speed is too high, then we see that the fusion problem generally occurs during welding. And if the travel speed is slow, then we can see that the higher heat affected zone is generally created nearby weld, and metal deposition is more during welding. So it should not be too high or should not be too low. It should be optimum travel speed while welding any component. Then second parameter is that the shielding gas flow rate. Then the shielding gas flow rate is actually unit is in liter per minute, and it ranges from 5 liter per minute to 15 liter per minute. And this shielding gas flow rates actually depends upon the size of the gas cup, the size of the weld, the welding positions, and the working conditions, etc. So and so on. So coming on to the welding of aluminium by gas tungsten arc welding process, we can see that always since aluminium is an active material, so it get oxidized easily and form aluminium oxide, and its aluminium oxide thickness is around 0.1 micron whenever it get exposed to the air. In order to weld these components, firstly this aluminium oxide layer should be removed, otherwise it will be difficult to weld aluminium. It will be difficult to weld aluminium with any process. So this oxide skin can be removed either by mechanical means, by using a file, shaper, different types of tools. You can mechanically rub it and then remove this oxide layer, or by using chemicals like different types of etchant available in the market. You can easily clean the oxide layer, but it is very tedious task to do chemical cleaning. Third is by you giving the electrode plus polarity. By giving the electrode polarity, this is the power source, this is the workpiece. But if you will connect this electrode with a positive polarity and this workpiece through negative polarity, then here electron will be accumulated, and whenever the arc get ignited, this electron starts moving from workpiece to the electrode. When this electron starts moving from workpiece to the electrode, then the oxide layer which is present here, it actually breaks this layer and goes to the electrode. But as you know, electron is having lightweight, and being lightweight, it can travel very fast speed, and due to this fast speed, high heat energy is produced, and due to this high heat energy production, this tungsten get heated up, and so the life of this tungsten get reduced. That's why during welding of aluminium, it is not advised to use direct current electrode positive, whereas we can use AC welding or more probably direct current electrode negative process. But through direct current electrode negative process, you can't weld aluminium. You can weld aluminium only through direct current electrode positive or AC welding, but direct current electrode positive is generally not preferred because it actually decreases the life of the tungsten electrode. In spite of it can remove the oxide layer. So, and another process, the use of the alternating current. So alternating current, first half cycle electron will move from here to there, second half cycle electron will move from upward to downward. So through this also the welding can be performed. Generally, actually there are two theories has been explained to remove the oxide layer. First theory is that the cathodic spot moving across the weld pool causes the aluminum oxide to evaporate. Cathodic spot means that the electron move from here to there and it actually remove the surface oxide layer, and the ion imparting means that the ion or the proton actually moves from the electrode to the workpiece, and this shatters the oxide layer present here. So coming on to the welding polarity, actually there are two types of welding polarity. First is the, in case of DC, direct current electrode polarity and direct current electrode negative. Direct current electrode positive is also known as reverse polarity, and in case of direct current electrode negative is named as state polarity. State polarity means electron moves from upward to downward, and reverse polarity means electrons move from downward to upward. So whenever a power source is connected through this electrode and the workpiece, and this is the positive and this is the negative, then then the electron will move from workpiece to the electrode, and the proton will move from electrode to the workpiece. So you can see where I have already, it is the general rule wherever the electron hit, there 2/3 of the total heat is generated. So where 2/3 of the total heat will be generated, then more heat will be generated, and it will melt that part where electron strikes, and where ion strikes, there 1/3 of the heat will be generated. So based upon these two, you can automatically say that 2/3 of the heat is generated at the electrode, and in here 2/3 of the heat is generated at the workpiece, because the movement of electrons and ions in case of direct current electrode positive and in case of direct current electrode negative, it is reverse of this. Then 1/3 of the heat will be concentrated at the base metal. Due to this, wide and shallow penetration is obtained, and here deep and narrow penetration is obtained, because in case of this electron directly hit here. If it hit here, directly hit, it means deeper penetration you will get, and ion will hit this. Since ion is hitting on the electrode, then ion is producing less heat. So here less diameter electrode you can use. By using less diameter electrode, the arc will be stringent, concentrated. So due to this, deeper penetration you will get. So alternating current, I have already told you that it is the intermediate advantage has been said in case of direct current electrode negative and direct current electrode positive. This is the principle of TIG AC arc welding. Again, here as shown that this is the oxide layer, it has to be removed. So you can see that in first negative half cycle, electrode become negative and workpiece become positive. Electrode hits the surface, penetration is obtained, and in second half cycle, this become direct current electrode positive, it become positive, it become negative. So electron will hit this electrode, but whenever electron moves from this to this, since electron is having higher velocity, then it actually break this oxide layer and move toward the electrode. So it break the oxide layer and it penetrates the base metal. So both advantages has been seen in case of AC welding. That's why we say that AC cleaning is seen whenever you have to weld aluminum with the help of gas tungsten arc welding operations. So always AC is recommended for welding aluminum with the help of gas tungsten arc welding operations. So these are the advantages and limitations. You can see that diverse number of materials can be welded with the help of these operations. Welding in all position can be done. It is spatter free, no slag is there as no flux is used during operations, and wire consumables not always required whenever you have to weld thin materials. Whereas the limitation is it is a highly expensive process, productivity is low, difficult in drafty environment, and a higher operator skill is required in case of gas tungsten arc welding because it is a manual operations. There are various advances in gas tungsten arc welding. There are 4 main advances: hot wire arc, hot wire TIG, 8K TIG, 8 TIG, and pulse TIG. One by one we will discuss. This is the K TIG operation. Actually it is the keyhole TIG process in which the high current is converted into the plasma current, and due to this plasma current a high speed is obtained and up to 16 mm thick plate can be welded with the help of this K TIG process. It doesn't require any filler material and any edge preparation through beveling operations in this process. You can see how it has been, KT has been performing here. And also very 10% of the shielding gas is actually used in case when you compare with other welding operations. This is the KT operations. In this oxide powder and acetone is mixed, and this thick paste is a first rub over the workpiece which you have to weld, and then with ordinary welding operations you perform welding. The advantage of using ATIG is that you can weld 5 to 10 mm thick 8 to 10 mm thick plates in a single pass with the help of ATIG process without using any consumables, as this actually decreases the surface tension of the base metal, which actually penetrates the base plate, and high deeper penetration is obtained in case of ATIG operations. Then third advanced welding operation is the hot wire TIG process. In this I have already explained you cold wire TIG process. This is hot wire TIG process. The difference between hot wire and cold wire TIG operation is that here AC hot wire power source is there, which actually used to melt this wire feeder, so that this wire doesn't get heated with this arc and doesn't cool this place. So if we firstly heat this wire at this point only, then the flowability of the base metal will increase, and you can see that the deposition rate will also be increased when you compare with cold wire transfer technology. You can see deposition rate and arc energy graph is obtained drawn here, and you can see that the deposition rate in case of cold wire is less and in case of hot wire is more. So this is the pulse TIG welding operations, and in case of pulse TIG, generally various types of in case of pulse TIG, base current and peak currents are generally used in order to weld any operations. Generally pulse TIGs are used in those areas where we want minimum distortion or no distortion, because a peak current is generally used to melt the electrode tip, and the background current is actually used to cool this interface at a time, so that we don't get a higher heat affected zone, so that the distortion get reduced. We can also change this pulse time, background time, pulse current, background current, depending upon our suitability with the help of these types of power sources. And the main advantage of pulse TIG type of power source is that we can also do overhead welding with the help of pulse TIG, as it is very convenient to control the welding current with the help of pulse TIG. That's why it is generally used for overhead welding operations. So coming on to the quiz session, first is which polarity produces the greatest penetration? AC current, direct current electrode positive, direct current electrode negative, alternating current electrode positive. So anyone can tell me? It is direct current electrode negative, because in case of direct current electrode negative, actually electron is hitting the workpiece, and higher deeper penetration is achieved in case of direct current electrode negative. Second is, what is the advantage of pulsed GTW? It must be automated for use in the overhead position. It increases the heat input of the arc, it increases the distortion of the part, it can be used in all welding positions. So you can say what should be the answer? It is that it can be used in all welding positions. GTW has these benefits. Okay, thank you class, thank you all the audience. If there is any question, you can mail me on Gupta Abhishek @akgc.ac.in. Thank you.